Welcome to lesson 4.7 on completing the square. So, here we've got a little picture of some of the general steps for completing the square, but I'll be going through that a little bit later in the lesson. It's good to refer to, though, if you forget the steps. All right, so completing the square. Before we get into completing the square, we want to recall some stuff. So, recall that a perfect square is a trinomial that can be expressed as ax plus b all in brackets squared. So when we factor it, it'll become ax plus b squared. If we expand this, so that's ax plus b times ax plus b, and we've done that in a previous lesson, we'll get ax squared plus 2abx plus b squared. And we're going to use this concept to help us complete the square. So let's see an example of expanding here. We're just going to expand these two binomials, these perfect square binomials. I'm going to start with x plus 5 squared. So x plus 5 squared, if we want to expand that, that's x plus 5 times x plus 5. So we'll use FOIL here. And when we use FOIL, we get x times x is x squared, x times 5 is 5x, 5 times x is 5x, and 5 times 5 is 25. We'll just collect our like terms, and we get x squared plus 10x plus 25. If we look up here, we see our middle term should be 2 times a times b, and then we add the x in. So in this case, a is 1, b is 5. So here we are, we've got b right there. So we've got 2 times 1 times 5, which is going to give us 10. So that's how we got this term. We use 2 times a times b. And I'll be using that in some other examples. Over here, we've got a slightly more complex perfect square, 2x minus 3 squared. So if we want to expand that, that's 2x minus 3 times 2x minus 3. 2x times 2x is 4x squared. 2x times negative 3, negative 6x. Negative 3 times 2x is also going to give us negative 6x. And finally, negative 3 times negative 3 will be positive 9. So once again, we can collect our like terms, and we'll have 4x squared minus 12x plus 9. And once again, if we refer back to our formula here of 2 times a times b to get our middle term, well, a is 2, b is negative 3. So 2 times 2 is 4 times negative 3 is negative 12. I'll be doing that again down here in 1 second. All right, so let's start to explore completing the square. First off, we're going to have you do a couple little warm up exercises. So, if these were perfect square trinomials, what would the middle term be? And we're going to refer back to our expanded form of the perfect square, ax squared plus 2abx plus b squared to help us find these. So, the first one over here is x squared plus some term plus 36. And we want to make this a perfect square. So we're going to use 2 times a times b to find out what that middle term is. So a is going to be 1. B, well, in order to get b, we know b squared is 36. See our formula here, b squared, 36. But we want b, so we have to take the square root of that. And we have a positive sign here, so we know we want the positive square root. So b equals the square root of 36, which is actually just going to equal 6. So now I can use my formula. 2 times 1 times 6 is going to give me 12x. So that would be my middle term that's going to help to make this a perfect square trinomial. Maybe pause this one here before I go through it and see if you can do it yourself. I've set it up for you. All right, so once again, we want the middle term. We're going to use 2 times a times b to find it. Well, a, that's our coefficient in front of x squared, which is just 1. B, well, we know b squared is 49, so to find b, we'll take the square root of 49. Once again, we're looking for the positive square root, and we see that from the positive sign here. So the square root of 49 is 7. So now, to find the middle term, we're going to do 2 times a times b, which is 2 times 1 times 7, which in this case is going to give us 14x. All right. So we've used that to find the middle term. So we can use that formula and we'll find the middle term. Well, what if we want to find the last term instead? So if these were perfect square trinomials, what would be the last term? And we're going to use ax squared plus 2abx plus b squared to help us find that. So here we've got x squared plus 12x plus some unknown number. We want to make it a perfect square. So what we need to do is use our little formula of 2 times a times b. We know a is 1. Coefficient in front of x squared is 1. So a is 1. And we don't know b, but we know that 2 times a times b is going to equal 12. So let me just scroll down just a touch here. What we're going to be able to do is, I know that 2 times 1 times b is just going to be 2b equals 12. So b, we just divide both sides by 12 to find b. B is going to be equal to 6. Now remember, our last term isn't just b, it's b squared. So what does that mean for us? That means 6 squared is 36, and that's the number that's going to complete that perfect square trinomial. All right, so try it with this one here. I'll let you pause the video for a sec, and then I'm going to go through the solution. All right, so once again, we're going to use 2 times a times b to figure this out. And when we look here, coefficient in front of x squared is 1, so a is 1. So we're going to get 2 times a times b equals negative 18. Well, a is 1, so really all we have left is 2b equals negative 18. Now we're just going to divide both sides by 2, and b is going to be equal to negative 9. Now, once again, our last term is b squared, so negative 9 squared is negative 9 times negative 9, and that's going to give us positive 81. All right, so we're getting the hang of this, but let's try 2 more here, and these ones are a little bit tougher. I'm actually just going to move them right down to the next page. So, x squared plus 5x plus some number. We want to make this a perfect square trinomial. So once again, we look here, the number in front of x squared is 1, so a is 1. So once again, we're going to get what we had before, which is 2 times 1 times b, or 2b, equals 5. So divide both sides by 2, and we're going to get, b equals, and I'm just going to use my fraction tool here. We're going to get 5 over 2. So that's what b equals, 5 over 2. But remember, when it comes over here, we want it as a squared. So What are we going to do? Well, we're going to square 5 halves. And we can leave it as a fraction. Just remember, 5 halves squared, we have to square both the top and the bottom. So let's put in my fraction here. Perfect. 5 squared is going to be 25. 2 squared is going to be 4. So there we go. We've got it all figured out. Um, the answer to this one, the last term has to be 25 over 4. Finally, we're going to do one where a is not 1. In this case, a is 4. The number in front of the x squared is 4. So a is 4. We want to find b. We know that 2 times a times b equals 12. So what that's really going to give us here is 2 times 4 times b equals 12. So that's going to be 8b equals 12. Now we got to remember, divide both sides by 8. So we're going to get b equals, and once again, just put in my fraction tool here, 12 over 8. And we can reduce that even more. 12 over 8, if we want to reduce that, we can divide both the numerator and denominator by 4. 12 divided by 4 is going to be 3. 8 divided by 4 is going to be 2. We get 3 halves. Now, remember, that's b, our last term. We actually want it to be b squared. So we're going to put in our fraction tool, and then we're going to square 3 halves. So when we square 3 halves, we have to square both the top and the bottom. 3 squared is going to be 9. 2 squared is going to be 4. So that's how we complete that one. So we use our 2 times a times b to figure out what b is and then square it, and that's our last term. And that's really what we're going to be doing when we're looking at completing the square. So completing the square is a method by which we make a complete square by adding a constant to a quadratic relation. For example, x squared plus 10x plus 15 is not a perfect square. It would be a perfect square if the last number was 25, not 15. So, and we can verify that a times b, or 2 times a times b will give us 10. And we know that b squared is going to be our last term. Well, 2 times 1 times b is going to be equal to 10. So 10 divided by 2 is 5. And then 5 squared, that's going to be 25. Whoops. So 25, if that was in there, we would have a perfect square trinomial instead of 15. So when we get equations like this, we're going to use the method of completing the square to do just that. We're going to make a perfect square. I'm going to show you how to do that now. So to complete the square, we'll use the following steps. Number 1, we're going to move any constants to the right-hand side of the equation. Number 2, we're going to add the constant that will make this a perfect square to each side to make sure we maintain the integrity of the equation. The left-hand side then can now be written as a perfect square. Then we're going to take the square root of both sides and then solve for x. And when we solve for x, we're going to find that we're either going to have 0, 1, or 2 answers, and those are our x-intercepts. So very similar to the quadratic formula, which we just learned about in the last lesson. All right, so let's see this in action. So let's use that example that we were looking at, complete the square and solve for x. So x squared plus 10x plus 15. Well, we already know what number we're going to put in there because we already kind of talked about that above. But let's just start off here. We're going to move the 15 to the other side. So we'll have x squared plus 10x equals negative 15. Positive 15 goes over to the right-hand side. It becomes a negative. Now, what I'm going to do is I'm going to complete this square here. So I want to find that third term that's going to make my left-hand side a perfect trinomial square. And in this case, we already figured that out above. We figured out that it would have to be 25 to make it a complete square. So x squared plus 10x plus 25 on the left-hand side equals minus 15. And we have to add 25 to the right-hand side as well to maintain the integrity of the equation. If we didn't add the 25 on the right-hand side, we've just completely changed the equation and it doesn't make any mathematical sense. So make sure what you do to one side, you do to the other side. All right. So we know the left-hand side is now a perfect square. We're just going to kind of tidy things up here a little bit. And I'm actually going to write this as a squared. So we know that this will go to x plus 5 squared. And that'll be equal to minus 15 plus 25, which is just 10. So all I did here from this step to this step is I factored. I said, I know this is a perfect square. In order to do that, I'm just going to look here. I know my first term has to be x because I have x squared with no coefficient. I know my last term has to be 5 because the square root of 25 is going to be 5. So that's an easy way to figure it out. Now I have x plus 5 squared equals 10. Once I'm to this step, I now am going to want to solve for x. The only way I can do that is to take the square root of both sides so I get rid of this squared on my left-hand side. So we're going to use the square root of both sides, and we're going to do the square root of x plus 5 squared, and that's going to be equal to plus or minus the square root of 10. You may ask, why plus or minus? Well, any time that I square a number, so I'm just going to use 5 here. Say I have 25 and I want to know what two numbers multiplied together to get that. That could be positive 5 squared, so 5 times 5 gives me 25. Or it could be minus 5 times minus 5, or minus 5 squared can give me 25. So I have to put this plus or minus here, and that's really, really key. So I've got plus or minus square root of 10 on my right-hand side. My left-hand side's just going to simplify to x plus 5. The square root and the squared are going to cancel each other out. So I'm just going to be left with x plus 5. And that's equal to plus or minus the square root of 10. I'm trying to solve for x here, so I need to take this positive 5 on the left-hand side, move it to the right-hand side. When I do that, it's going to become negative. So then I've got x equals minus 5 plus or minus the square root of 10. And if you watch the quadratic formula video, you saw in that lecture when I've got this, really it can be broken down into two separate equations. I can have x, in this case, x equals minus 5 plus the square root of 10, or I can have x equals minus 5 minus the square root of 10. So we'll take both roots. So we're going to split this. It's going to become two equations here. And I'm actually going to do the square root of 10. You can leave it in root form if you want. That is totally up to you. So I'll have x equals minus 5 plus 3.16, or x equals minus 5 minus 3.16. Now I'm just going to solve those, and I'll know what my x-intercepts are. So x equals negative 1.84 or x equals negative 8.16. Those are my x-intercepts of my original equation, which was x squared plus 10x plus 15. If we wanted to verify that, well, we could do that. We'll just flip over to Desmos. I'm going to just hide that one for right now. And I'm going to type in x squared plus 10x and plus 15. And if I look here, let's just come down a bit. My x-intercept, that's where my parabola crosses my x-axis. I've got negative 1.838 and negative 8.162. Those are my x-intercepts. I go back here. Yeah, 8.162 and negative 1.838. So negative 1.84. We're just off a little bit due to rounding. I rounded to two decimals here. And negative 8.16. So we've got our x-intercepts. It works out. The other thing we could do is we could sub these numbers one at a time into our original equation, and our equation should equal 0. All right, so that's our first completing the square. We're going to go through, we're going to complete another square and solve for x. This time we've got x squared plus 5x plus 1/4. All right, so we're going to follow the same steps. We're going to move that 1/4 to the right-hand side of the equation. When we do that, it's going to be negative. So we'll have x squared plus 5x equals minus 1/4. Now I'm going to follow my same process I followed before. I want to find the number that's going to make this a complete square. And I can use my 2ab, so let's just pull out my marker here. I know that 2 times a times b is going to be equal to 5. It has to be equal to my middle term. So what do I know? I know that a is 1, so that's just going to be 2b is equal to 5. I'll get it written up here eventually. There we go. So I know what 2b's are. I just want to find out what 1b is. So all I'm going to do is divide both sides by 2, and I get b equals 5 over 2. Now that's fine, that's b, but we need to square that to complete the square. 5 squared is going to be 25. 2 squared is going to be 4. Remember, what I do to one side of the equation, I must do to the other side. So on the left-hand side, I've got x squared plus 5x plus 25 over 4. And on the right-hand side, I've got that equal to negative 1/4 plus 25/4. Good news, we don't have to find a common denominator because we already have one here. So we can consolidate that. And we're going to express our left-hand side as a binomial squared. And that's going to be x plus 5 halves. So x plus 5 halves squared equals minus 1/4 plus 25/4 is going to be 24/4. At this point, this one will actually simplify for us. It's very nice. They rarely work out that way, but 24 divided by 4 is 6. So this is what we have. We have x plus 5 halves squared equals 6. Now we want to solve for x. So that means we need to take the square root of both sides. Remember when we put the square root on the left-hand side, the square root and the squared are going to cancel out. So we'll just be left with the x plus 5 halves. So square root of x plus 5 halves squared equals plus or minus the square root of 6. That plus or minus, don't forget that. That's very important in these questions. So the left-hand side of the equation is just going to go to x plus 5 halves. And on the right-hand side, we've got plus or minus the square root of 6. Well, we want to solve for x, so we've got to get that 5 halves to the right side of our equation. It's going to become a negative. So we get x equals negative 5 halves plus or minus, and I did the square root of 6. It was 2.45. So this means that I have to split this into two equations. I'm going to have x equals negative 5 halves plus 2.45 and x equals negative 5 halves minus 2.45. And now I'm just simply going to solve. 5 halves is 2.5, so I'm just going to use decimals here. 2.5 minus 2.5 plus 2.45 is going to be minus 0.05. And over here, minus 2.5 minus 2.45 is going to be minus 4.95. So those are my x-intercepts at x equals negative 0.05 and x equals negative 4.95. All right, let's take a look at one more here. Whoops. And this one, we're going to have a number in front of the x squared. Well, when we complete the square, we don't like that. Whenever we've got a coefficient in front of x squared, we're going to divide the entire equation by that. And in this case, I'm actually going to just factor it out of these three terms. There's another way we could do it, but it works out really well for this one if we just factor it out. Both ways are appropriate. The other way we could do is set this equation equal to 0, divide both sides by 2, and that gets rid of the coefficient in front of x. Well, we're going to do that at a later state. So right now what we're going to do, we're going to factor out the 2. So when I do that, 2x squared divided by 2 is going to be just x squared. 8x divided by 2 is going to be 4x. And I'm not going to divide the positive 12 by 2. I'm going to flip that to my other side because my constant has to be on the right-hand side. So I've got 2 times x squared plus 4x equals negative 12. And remember, my distributive law, I haven't changed anything. This is still, if I distributed the 2x squared plus 8x, and the 12 is on the other side as a negative. So I haven't changed anything in my formula. That 2 is very important, though, because what we're going to do is we're going to complete the square inside the bracket. And I'll tell you when we need to use the 2. So first off, we're going to complete the square within the brackets. So a is 1, 2 times a times b equals 4. So really, b is just 4 divided by 2, which is 2. So if we square 2, we get 4. So we're going to do that. I'll talk about the right-hand side of my equation in a second. But here we've got 2, and then in brackets, x squared plus 4x plus 4. So inside our brackets is a perfect square trinomial. Now, you might ask, well, why didn't I just add 4 on my right-hand side? I added 8. Well, that's because this 4 isn't really a 4. We factored that 2 out of it, right? So 2 times 4 is 8. So I actually, by putting plus 4 inside the brackets, I actually added 8 to my left hand side of the equation. So I must add 8 to my right hand side of the equation. Hopefully that made sense. And so now x squared plus 4x plus 4, well, that's the same as x plus 2 squared. So I've got 2x plus 2 squared equals negative 4. All right, now I want to try and solve this. So the first thing I'm going to do is I'm going to divide both sides by 2. And so I'll get x plus 2 squared equals minus 2. Now I'm going to take the square root of both sides. And you might already see the issue we're going to encounter. Square root of x plus 2 squared, that's just going to become x plus 2. But that's equal to the square root of negative 2. And I highlighted that in red because we cannot take the square root of a negative number unless we want to get into imaginary numbers, which we're not going to get into. So, what does this tell us? Well, we've got the square root of a negative number. We can't do it. That means that there are no x intercepts. I'm going to show you one more cool thing with this, but let's just verify this in Desmos. So my original equation was 2x squared plus 8x plus 12. Let's flip over to Desmos. And I've already been prepared for this one. So 2x squared plus 8x plus 12. And lo and behold, we look and we see, oh, well, my vertex is at minus 2 and positive 4. This parabola never crosses the x-axis, and that's why it has no roots or zeros or x-intercepts. So it does not have any x-intercepts. That's why we had the square root of a negative number there, because we can't solve it. There are no roots or no x-intercepts. Now, right before I let you go, I just want to show you something pretty cool here. So I'm going to just go back to this step here. If I didn't solve for it, we might notice that this is looking kind of familiar. What I'm going to do is I'm going to bring this minus 4 back over onto the left side of the equation. And I think this is really neat, and we're gonna see this in Friday's lessons, anyways. So let's just show it to you now. I'm gonna just rewrite this. So we got x plus 2 squared, and when I bring that minus 4 over to the other side, it becomes a plus 4. I'm just gonna have that equal to 0. And we may notice something about this form. So let's just take one more look at this. If I pull that right out and I just leave it as a relation like this, you might recognize this as the vertex form of a quadratic equation. So completing the square, we just went from a standard form quadratic relation to vertex form quadratic relation. So just a little prelim to what's coming up on tomorrow's videos. That's one of them. And now we can verify. We verified already with Desmos that there was no roots. But here, when vertex form, so we know our vertex is minus 2 plus 4. It opens upwards. That means it's never going to cross the x-axis. I hope you found that as interesting and fun as I did. Thank you for watching the video on completing the square. You're now ready to go on to the quiz or do some homework questions first to make sure you understand the concepts, and then you can go on and write the quiz from there. Good luck on the quiz. Thanks for watching. We'll talk to you later.